welcome back to course Database Management System. So our today's topic of video is Introduction to Transaction and Acid Properties of a Transaction. So transaction is very important topic as far as database is concerned, and based on this topic you may find 2 to 3 marks question in a GATE exam, and that question is very easy. So for that purpose you should know what is transaction. So this transaction concept and topic also important for your exam point of view, university exam point of view also, then your interview point of view also, as well as for your technical exams. So here we try to understand what is the concept of transaction. Okay, so there are n number of things are there related to transactions, and n number of definitions are available related to transaction, that what is transaction, why transaction is being used. So in short I can say transaction is nothing but a change. Here I mention that transaction is nothing but a change. So before explaining what is transaction, I will tell you some example that where you find generally it is observed that most of the time, suppose I ask any student what is transaction, they say that sir, in bank I heard about transaction. So is it the case that transaction is only related to bank? No, it is not a case. Transaction is not only related to bank, but in other domain also there exists transaction. So here I mentioned one simple example, booking railway ticket, booking air ticket also considered as one of the transaction. Suppose in case of your library system, suppose you are issuing any book, that is also considered as a transaction. If you are returning a book, if you are renewing a book, that is also considered as a transaction. So transaction means what? Transaction means what? A change. So now let's discuss what is transaction. So it's a minimal set of changes which takes your database from one consistent state to other, with the restriction that whatever the changes that you have made, that would be done by single session, and once committed changes are guaranteed. This is what a transaction. In the broad way we can define the transaction in this way, that it is a set of minimal set of change that you are going to do, but it should bring your database from one consistent state to another consistent state, and all the changes must be done by single session. It is not a case that some of the changes made by one session, another changes is done by another session. This thing should not be there. All the changes should be made by only one session, and once committed, changes are guaranteed. That means once you make a change, that should remain as it is. It should not be the case that suppose I want to transfer 100 rupees from account A to B. So I have just transferred 100 rupees and then suddenly it is deducted from account A, but after that suppose that change get undo. So what will happen? Again I can see that same amount in the previous account. This thing should not be there. Once you make a change, that change should be saved. Okay, so this is then in another way, how can we define transaction? In other way we can say that transaction is a set of one or more operation which is carried out sequentially. Okay, means it is a set of one or more instruction. It is not a case that every time only 2 instruction, 3 instruction, n number of instruction can be there in a single transaction. That's why in another way we can define transaction like that. It's a set of one or more operation which is carried out sequentially. Just take a simple example here. Suppose I want to transfer 100 rupees from account A to B. So what set of instruction I need to perform over here? First of all you need to read A, then you need to deduct 100 rupees from A, then you have to perform write operation on account A, then you need to perform read operation on B, and then you are going to add 100 rupees to B, and finally you will perform write operation. So this complete template, this complete package considered as a transaction. So in this case what is important? Now again come back to this definition. It's a minimal set of change which bring your database from one consistent state to another consistent state. So in this case what do you mean by consistent state? So in this case, suppose initially in account A 200 rupees is there, in account B 300 rupees is there. So total together A and B 500 rupees is there. So suppose I'm going to transfer 100 rupees from A to B. So after transferring, what is the new situation? That in B 400 rupees will be there, and in A only 100 rupees will be there. So before transaction, total of both these account is 500 rupees, and even after transferring 100 rupees from A to B, again the addition of both is 500. That means this is what a consistent state. Okay, this is what a consistent state. Okay. And it is done by single session. It is not a case by, it is done by multiple session, and once committed, changes should be guaranteed. Again, we can say that transaction is a logical unit of work. Okay, and transaction always involves set of instruction. Mostly you find read and write. These are two major instructions are there in case of a transaction. So again, I say that transaction is a term which is not only related to banking, but the transaction is a term that you aware about in multiple domain. I have just given you the very good example in case of library. Suppose you are issuing a book, that is considered as a transaction. You are returning a book, you are renewing a book, that is also considered as a transaction. So transaction is a logical unit of work. And in short, you need to remember, transaction is what? Change, but that change should satisfy this thing. Okay, this thing should be satisfied. Now next we are going to discuss about the acid properties. What are the properties of transaction? Now the question is that why there is a need of properties, whether the properties are necessary for any transaction to satisfy. So the answer is yes, and these properties are very much necessary. Now I will give simple example to illustrate why these properties are important. Now just imagine a situation that I am transferring 100 rupees from A to B, and after deducting 100 rupees from A, there is a failure in the system. Okay, there is a failure in the system. So in that case, what will happen? That 100 rupees is deducted from account A, but it is not being added to account B. So where that 100 rupees goes? Whether this is a desirable situation? No, it should not be there. It should be controlled. So in that case, what is desirable? That 100 rupees should revert back to previous account. So this is what a desirable thing. Again, suppose two person at the same time try to access a particular account, and both will withdraw the same amount of money. Suppose initially 1000 rupees is there, and minimum balance condition is of 500 rupees, and both person A and B will get 500 rupees from this account. So whether it is desirable? No, it should also be controllable. And once you make change that you are transfer 100 rupees from A to B, you are deducted amount, and initially 500 rupees is there, so I have deducted 100 rupees from account B. So what is the new value for account A? It is 400. But I have just deducted this amount, but suppose I check again, I found that in account A there is a 500 rupees. That means whatever the change that I have made is not being saved. So what is required? You need to save that changes. So that's why the properties of transaction play very important role. So it is a part of your transaction management. Only performing transaction is not enough. You need to take care of this, that transaction should execute in a proper manner. So this proper execution of transaction will be done by with the help of these four types of property. One is atomicity, consistency, isolation, and durability. So these are the four acid properties are there. Their acronym is acid. A for atomicity, C for consistency, I for isolation, and D is for durability. So these are the four properties of transaction is there, which is desirable in order to make sure that your transaction will execute in the proper way. So let's try to understand all these four property one by one. So very first we'll discuss about the atomicity. So in short, first of all I will give example, and then we try to understand what is atomicity. So atomicity means what? Again the same example. I want to transfer 100 rupees from A to B. Okay, so initially I just read the value of A, I just deduct 100 rupees from A, then I perform write operation on A. Then imagine situation after this there is a system failure. This 100 rupees is deducted from account A, and after that there is a failure in the system. So in that case what will happen? Whether that 100 rupees get lost because it is deducted from account A but it is not being added to B. So where that 100 rupees goes? whether it should be lost? No. So in that case, what is desirable? That 100 rupees should revert back to account A. Most of the time it may happen with you. Suppose you are using any UPI. Generally it is happen with a Google Pay, that whenever you try to transfer money from your account to any other's account, so in that case money gets deducted from your account, but still it is in processing state. So in that case, what happen? That whatever the money that is deducted from account A, but it is not being transferred to another account. So in that case, what will happen? After some time, that money will get returned back to you. Why this is happening? This is happening just because of atomicity property. Now I will give statement. What is a atomicity? Atomicity means what? Either all or nothing. That means either all operations in one transaction will get executed or nothing will be executed. Either all or nothing. So in this transaction, and initially what I told you is transaction is a set of operations. So total 6 operations or 6 instructions are there. So either I will execute all these instructions or I will not execute any instruction. So this is what a case. So atomicity means what? Either all or nothing. And just because of this atomicity property, you are getting your money back in your account. So this is what a atomicity property. Now the next is a consistency. So consistency property is maintained by this atomicity, isolation and durability. That's why first of all we understand isolation and durability property, and then we will come back to consistency property, because consistency property is being maintained by this isolation and the durability property. So what is isolation? Next property is what? Isolation property. Now what is isolation property? So what is the meaning of isolation? Okay, what is the meaning of isolation? Isolation means what? Isolation means what? Alone. Now in order to explain isolation, I will give a simple example that what is isolation. Generally we go to mall, generally we go to particular mall to purchase a cloth. So at that time, in order to purchase before purchasing particular cloth, you will just try this. So you will try how that particular cloth will look like on you, and whether it is its fitting is okay or not. So for that purpose, what you are doing, you are going to use the changing room. So in changing room, so in particular mall, n number of changing rooms are available. See, isolation can be a physical isolation or it can be a logical isolation, but we want that our task has to be executed. So in case of mall, n number of trial rooms are available. So we just consider scenario 1. In scenario 1, total 10 trial rooms are there, and you went to that mall and you want to try a particular cloth. So all these 9 trial rooms are vacant, so you are going to use the 10th room. Okay, so in that case nobody is there. So this is one. This is a physical isolation as well as a logical isolation. Physically you are isolated because nobody is there, but now in the scenario 2, all these 8 trial rooms are already filled and you are going to use trial room number 9. So this is what? Logical isolation. Means physically already 8 people are there, but they are separated. Means the execution of one task should not be interfered by other. In the scenario 1 also, you are using trial room, only one trial room you require. Your task get completed, that you are going to wear the cloth and you will check for fitting. And in the scenario 2 also, in scenario 1 nobody is there, you are alone, but in the scenario 2 8 more person is there, but still you are going to use that cloth and see what is the fitting of that cloth. So in the second scenario, we can say that it's a logical logical separation. Okay, logical isolation. So isolation means what? Isolation means what? Separation. Means why isolation property is required? That execution of one transaction should not interfere with another. Otherwise what will happen? Just come back to that example, that suppose 2 person want to change their cloth and they are sharing one room. Is it happening? No. In one room only one person will be there, so this is not possible. In the same way, particular data item can be used by only one transaction at a time. Means otherwise what will happen? Only one ticket is available and it is being booked by n number of passengers. Is it happening? No, because only one person can able to book a particular ticket and other will get a waiting ticket. So this is what a isolation property, and isolation property is maintained by concurrency control mechanism that we are going to learn. So concurrency control mechanism ensures the isolation property of a transaction. So according to that isolation property, every execution of one transaction should not interfere with another transaction. So it states that execution of one transaction should not be interfered by others. So I hope you understand what is isolation property, and it's very good example. Another example is joint account. Suppose two person A and B having a joint account, okay, and in their account only 1000 rupees is there, and both person A and B both want to withdraw 500 rupees from the account. So whether they able to withdraw the money from account, is it happening? No, they are not able to. They were not able to withdraw the money from the account. Okay, they were not able to withdraw the money from account. Only one person will get 500 rupees and another person will get a message that insufficient balance is there. So this is what a isolation property. And the next property is a durability. So durability means what? Once you make change in the database, that should remain as it is. I just given you the example that 100 rupees is transferred, 100 rupees is deducted from A and it is not being added to B. Okay, means 100 rupees is deducted from A, and after some time again I see same 100 rupees is present in account A. That means whatever the change that I have made is not saved permanently. This thing should not be there. So once you make change in the database, that should remain as it is. And if the durability property is satisfied, so who make sure that durability property is satisfied? Recovery mechanism, that we are going to also discuss. Recovery mechanism ensures the durability property of a transaction. And suppose durability property, isolation property is satisfied, then your consistency properties also get satisfied. Now what is consistency? Consistency means what? Accuracy. We can say that it's a measure of accuracy. Consistency is nothing but a measure of accuracy. Now I will tell you what is accuracy with the help of same example. Initially in account A 200 rupees is there, in account B 300 rupees is there. So together A and B total 500 rupees is there. So 100 rupees get deducted from account A, it is being added to account B. Now in the after execution of this transaction, what is the new thing? Again in account B 400 rupees is there, in account A 100 rupees is there. But if you add both this value, you are getting 500. So before transaction addition is 500 and after transaction even also addition is 500. That means this is what a consistent state. So in that case, what is a inconsistent? Suppose after addition their addition is only 400. So we say that this is not a consistent state. So consistency means what? Means accuracy. Before transaction and after transaction, consistency should be same. So it's a very good example is maintaining the minimum balance condition in the bank. In most of the bank, you know that minimum balance condition is 500 minimum 500 rupees should be there in your bank account. So suppose you perform transaction and after performing the transaction, suppose 500 rupees is not there in your account, then we say that this condition, this state is not a consistent state. So we want that before transaction and after transaction, your database should be in a consistent state. That means it should maintain the accuracy. So this is what a consistency property. So if isolation and durability property is maintained, then ultimately consistency property is also being maintained. So these are the 4 important properties of transaction which ensures that your transaction will execute in a proper manner. And this is very, very important as far as your banking is concerned. And transaction is not the term which is only related to banking, but it is related to other domain also. So what atomicity we have seen? Either all or nothing. Either all instruction will be executed or nothing will be executed. Consistency means what? You have to maintain the accuracy of a database. Isolation means execution of one transaction should not interfere other. And durability means what? Once you make change, it should not get it should get saved permanently. So these are the properties of transactions. Thank you.